Hello, everyone. Glad you are with us today for our opening episode of the What Works series. This is practical advice from Eckerson Group Consultants. We did a similar series in the fall and it was very successful. We had a lot of people attending with a lot of great questions. So we decided to do it again. And we've got a new lineup with some new faces, new topics. So very excited to dive in, and I hope that you can join us for every episode, but if not, for the ones that you can make. So this is the lineup. Today, we're very fortunate to have my colleague, multiple time colleague, Dave Wells, talking about rediscovering the lost art of data modeling, a very timely topic. And then in our next episode in March is with Brad Schwartz, who was actually a consulting client of ours when he worked at Intel, and now he's a data leadership coach. So I decided to invite him on to see what gems of wisdom he has for all of you data and analytics leaders. Then we'll also hear from Sean Hewitt on the art of data valuation, March 25th, and then Rich Fox on effective ways to turn analysis and insight into action. April 19th, we'll do Data Literacy 2.0, following up on Josh's first session in the fall. It's going to dive a little deeper into data literacy and how to do it in a practical way. And then finally, we'll end up with Carlos Bassi, our data architect, talking about the medallion architecture and creating data zones for all consumers. So we're kind of sandwiching everybody between two data architects, Dave and Carlos. And I think we're talking right now of doing a bonus episode on how to create a Gen AI strategy, because we're working with some clients to do exactly that right now. It's a very interesting area. So for those of you who don't know us, Eckerson Group, we're glad that you're here. We're glad that you're with us. We're kind of a small boutique research and consulting firm. We like being small and boutique-y. We think we provide lots of deep expertise that you can't get at the bigger firms. All of our consultants are senior consultants with at least 20, I would say 25 years of experience, and some, like Dave and I, more than 30. And I think the thing that we do best, at least on the consulting side, is we listen carefully, synthesize accurately, and collaborate deeply. And we give you bespoke solutions for whatever issues you want to address. These are the areas that we typically consult in. Do a lot of data strategies, a lot of data architecture modernizations, and a lot of data governance. Those are probably the three big ones. When we do data strategies, we oftentimes dig down deep into operating models and literacy, self-service analytics. We also occasionally touch on data ops and data science. This is our small but experienced team. We did count one time how many years of experience with this group, and it was over 200. So as you can see, very senior. And these are some of the clients that we've had in the recent past. So all industries, Europe, Canada, mostly US, medium-sized, large, brand name, and not. So it's been a fun ride working with all of these organizations, mostly on strategy and design, not so much implementation, although we can do that. All right, so that's the preview. So it's my great honor today to introduce Dave Wells. He and I go way back. He and I both worked at the Data Warehousing Institute for many years. I was a director of education. And then after a year, I decided that I would pass the reins of that job on to Dave, who had a hell of a lot more experience in education and training than I did. And I went and started the research group at TDWI. And then when we both left and I started Eckerson Group, Dave came on board as our first analyst, writing reports and articles and giving speeches and doing webinars like this one. Now he's trying really hard to retire, so I don't like to bug him too much. But he did agree to come on and talk about one of his areas of expertise, which is data modeling. And what's really interesting about this topic today is that a lot of the new generation of data and analytics professionals don't know how to do data modeling, and they don't realize they need to know until they hit a brick wall and start kind of hardwiring their dashboards and reports directly to operational systems, and then wondering why they're doing so much rework down the road. So Dave's going to talk about that and many other things and give a broad overview. And again, the beauty of these sessions here is that they're not sponsored, for one, and we can talk about whatever we want, for two. And three, you in the audience get to ask any question you want, and we will answer it. I will be watching the Q&A. So add your questions to the Q&A tab. I'll be watching those, and I'll inject those into the conversation as we go. So Dave's going to present the slide, and then we're going to stop. I'm going to make comments, ask questions, and take your questions. And so we want to make this very interactive. Don't be shy. If you just have a comment, put it in there, and we'll bring it to the light. So with that, I am going to introduce Dave and stop sharing and let him take over from here. So give us a second, folks.
Okay, so as Wayne said, the topic is rediscovering the lost art of data modeling. I refer to it as a lost art because it is something that we did for many, many years. In fact, just to look back to Wayne's intro slide for me, he gave me 40 plus of data information management. I wish that young. I started out as a programmer in 1968. So it's a little bit more than 40 years, but I learned data modeling in the mid 1970s. In fact, somewhere behind me on the bookshelf, I have the original Peter Chen papers. Peter Chen is the guy at Louisiana University who first introduced the whole concept of entity relationship data modeling. So I lived through 30 years, 40 years of dealing with a core practice. Then in recent years, we've sort of abandoned that core practice and stopped paying attention to data modeling. That's a lost art, but I think it's still a really important thing for us to be doing. As Wayne said, a lot of the younger developers haven't been introduced to data modeling, don't know what it is, why it's important, or why it's needed. So this is kind of my soapbox topic for right now, is we need to begin data modeling again. So with that, if we look at how data modeling has from the past to the present, many organizations have abandoned this data modeling practice. They shifted from more traditional kinds of things that we used to do with data to big data, data lakes, unstructured data, NoSQL, and somewhere along the line, along with NoSQL, came no data models. But when we think about the contrast of these things, in the past, data modeling focused only on relational data, and it was typically logical and physical design. It was about designing databases. It's not surprising as we come to these more complex things. Traditional data modeling practices didn't fit well, so they didn't get used. Well, that's an unfortunate thing because we really do need data modeling. We just need to do it differently so that we can get the right kinds of results. So instead of just logical and physical modeling to design relational databases, we need semantic modeling to understand data in business context and with standard vocabulary. We need conceptual modeling. We understand it from a business point of view. We need logical modeling for system design. We need physical modeling for technical design. And we need different kinds of models depending whether we're modeling relational data or document stores or graph databases or whatever. We need to model to understand the content and structure of the data that we're working with, whether we're creating it or we're acquiring it from external sources. And we need to understand it at all of these levels. So data modeling is much bigger and much more complex now than 25, 30 years ago. But it's also more important. With that, stop and ask for questions.
Well, I forgot to mention something, Dave, when I introduced you, which is that of those 200 years, you probably have the most of any of the consultants listed there in terms of experience. So you're leading the pack. A lot of us are not too far behind. I also forgot to show the special offer, which is the first 3 people who put something into the chat, and Julie will be watching. If you want 30 minutes with Dave, we'll schedule that. All right. So if you're interested, put that in there, and we'll get you a special one-on-one with Dave going forward, or me if you want. Yeah, so Dave, you made this comment about data modeling today. On one hand, people aren't doing it; they've forgotten how to do it. They haven't been told they need to do it. And on the other hand, it's much more complex because there's many more different types of databases that require different kind of modeling. So I'm wondering, on that latter point, if we have like a graph database or a NoSQL database, a document database, how does that change the modeling? Do you do more or less semantic modeling, or do any of those layers change significantly? Is there any rule of thumb you can say there?
I wouldn't say the layers change so much as the kinds of models change. We can't do it all with entity relationship modeling. So we need different kinds of modeling for graph databases. We need different kinds of modeling document stores. In fact, in a little bit, a couple of slides from 2 or 3 slides from now, I'll how many different kinds of data models there are.
Okay.
And so there's more modeling techniques to learn, there's more modeling skills to learn, there's more representations of models. And interestingly enough, I think this whole NoSQL data modeling space is still evolving and still changing. There's probably the most mature of the tools out there for it is Hackleade. And they have particular modeling some of this stuff. Steve Hogan Technics Publications is coming out with quite a series of books about NoSQL data modeling. But entity relationship modeling for years was the de facto standard for relational data modeling. Today we have no de facto standard for all of these variations of NoSQL databases. It's still evolving and has yet to solidify into something that everybody agrees on.
Cool. Hey, we got a question from C Dove, and folks, please put your questions and comments in. What are the approaches to create conceptual and semantic models when it's difficult to get business backing, particularly in the agile mentality? It's a good question.
Good question. Business backing is a challenge because you can't really do semantic modeling in particular without business subject expertise. I can't offer you any really strong cultural suggestions for how the business in. What I can say is to get deeper into this material today, I'll touch a little bit on especially the value of semantic modeling for what I refer to as data interoperability. And that may be the key to getting business backing, is not so much that we need semantic models, because semantic models probably sounds like Charlie Brown's teacher to a lot of business people. So if instead of talking about semantic models, talk about being able to different databases to interoperate, to talk to one another in a way that helps different business functions to collaborate and interoperate. Maybe that's a better sell for getting some business back.
Yeah, I would also add that the business is much more receptive to anything that you do that's technical. If you've proven some success and given them some value, then they're more willing to sit down and listen to you and participate. But until they get that win, sometimes it's really hard to get their backing. So why don't we move on, Dave?
Okay. So, in my opinion, every data professional today needs to have some data modeling skills. So here you can see where I've listed several roles and a few of the kinds of questions for each of those roles where data modeling may help them. Obviously, we don't have time in a 1-hour session to go through all of these roles and talk about them, so I want to call out the top 2. I put data engineers and data architects at the top of the list. Data engineers because they need to be engineers as well as process engineers. Right? Data engineers are building data pipelines. They're building processes. But we're working in a world where everybody's talking about data products. Data meshes, data products. Lots of architectural drive toward data products. Data products is part of data monetization. If you're going to build the data products, you need product engineering discipline. And for data products, product engineering discipline means data model, data product model. So I put data engineers top of the list for that reason. And I put architects second on the list because I believe today's biggest architectural challenge is data interoperability. And I'll come back to that again in a couple of slides. But you can't achieve data interoperability without data semantics, and you can't achieve data semantics without semantic modeling. So everybody who works with data in one way or another needs some grasp of data modeling.
Yeah, so I want to ask you a question, Dave, but here's my question. I'm hearing a lot today about the role of analytics engineer, and there's different definitions of it, but it's a kind of the citizen's version of the data engineer, kind of like a Uber data analyst who sits out in the business and is building stuff, perhaps doing more than just building the dashboard, building the pipeline that feeds the dashboard, right? And a lot of these analytics engineers these days love to use DBT. And this is the group, I think, that has never been taught how to do modeling. DBT, I think, kind of recognized this last year, and they came out with this semantic layer, which is essentially, oh, guys, don't forget to build some models in the background, or else you're going to be doing a lot of rework. Have you heard about this role of the analytics engineer or the DBT people who are always building stuff in Python?
I have not sort of react to it as the idea begin to put labels on things before they're well defined.
Right.
Some of that grows out of the world of marketing. I think this is another case where maybe a year from now we will actually understand what an analytics engineer is.
Yeah.
And be able to frame some roles and responsibilities around it. Regardless of the label we put on these, if you're building data feed, databases, data pipelines, data whatever, if you're building data feed, data modeling needs to be part of your skill set.
Yeah, absolutely. All right, let's move on.
So I mentioned lots and lots of different kinds of data models. Past data modeling was almost entirely entity relationship modeling, and in the later years, dimensional data modeling. So much of dimensional modeling was limited schema. That's what people looked at was schema data model. So be honest, when we call it schema, we're talking about physical models. When the things we model are tables, fact tables, and dimension tables, we're clearly working with physical modeling. So we did lots of multi-dimensional data without even looking at logical models. So we need logical models for multi-dimensional data, where we talk about things like meters and measures instead of fact tables and dimension tables. We still need entity relationship models, but we need some other kinds of models. In the lower left here, you can see a graph data model. Okay, this is knowledge graph. We can extend it to property graph and be able to see in ER language, we can begin to see attributes as well as entities. But graph data modeling is different than entity relationship data modeling. On the far right, you see one form of a document store data model, and there are lots of different variations for how document stores are being done right now. So what we have going on is lots of different kinds of models because we have lots of different kinds of data in SQL world. Data that we sometimes call unstructured, but is really differently structured. And for differently structured data, we need different kinds of data models.
Dave, Mark asks, what data model would you use to support knowledge graphs and digital twins? That's a tough one.
Knowledge graphs, I would absolutely use graph data models. And I guess the property graph data model could effectively represent the whole digital twin space. I guess I'd go down the path of knowledge graphs, perhaps extended with taxonomies embedded in the knowledge graphs.
So, Dave, just tying this back to your first chart, could you say that what you're representing here, is that at a certain level? Is this at the conceptual level here or the physical? Because you mentioned that we're all too at the physical.
Yeah, especially if I'm working with graphs, I'm at least starting out conceptual. Ideally, I'm starting out semantic,
Yeah.
then conceptual, and then progressing to logical. And there is a physical component if I'm going to implement in a graph database. There is a physical aspect to it, and then the question becomes what kind of graphs am I really looking at? Neo4j kind of database? Am I looking at a graph? And am I wanting to represent my data as key value pairs? Or am I wanting to represent my data as RDF and L? So, as I get closer to physical, it becomes more tightly bound to what's the technology I'm using.
Yeah. So I have a question. So what is, I always thought the star schema was a multidimensional model, but you've got them depicted separately here. Is that true? Star schema is a version of the multidimensional?
Star schema is the physical model for a multidimensional model.
Okay.
But the logical model needs to be something that's not about tables, not about primary keys and foreign keys, but more about business concepts and system concepts. The star schema has collapsed the hierarchy, but the truth is when I'm rolling up and down hierarchy, those business concepts, I need to see all the levels of hierarchy in a logical.
Yeah. Got it. Right, which you depict in that multidimensional representation. Right, you depict the hierarchy for rental and vehicle. Yeah.
Right.
Okay. All right, folks, ask your questions, make your comments. We'll bring them in. Why don't we move on, Dave?
Okay. So what we have going on today is lots and lots and lots of data. I want to bring this idea of interoperability, and we have data sources everywhere, and we're not going to resolve all of this with copy-based integration. We can't keep making copies of copies of copies and trying to hammer data into rigid schema to get data to work together. We have an operational world where most organizations now are a combination of legacy systems, SaaS applications, ERP, lots of commercially available systems, and every of those has its own unique data organization, terminology, encoding, formatting, and different semantics in every one of these purchased applications. Still, we have the overlaps and the redundancy. Trying to resolve all of that is a lot of noise. Then we have in the analytical world, we never did quite get that single version of the truth. I've recently run some show of hands kind of polls when speaking, and I find most organizations today have somewhere around 5 or 6 data warehouses. And then we've got Italy. So to try to bring all of this together, we need something more than data integration. We need data interoperability. We need these things to be able to talk to one another, to communicate across different data silos. And that's interoperability, and interoperability depends on a common shared language that we can map everything to. Interoperability depends on semantics. We don't get semantics without semantic models.
Great. All right. Well, we didn't see all these questions coming in. Okay. Got some more questions for you. But here's the question. Clearly, so-called data teams and others who operate in the cloud-based modern data stack never adopted modeling. On the other hand, have IT and data teams still working with relational on-premises databases also abandoned data modeling?
I'd say not all of them have abandoned data modeling. Most of them probably still practice some amount of data modeling. Many of them make modeling in their relational world, haven't extended it to reach out to NoSQL. Maybe they model their transactional systems, but not their data lake. I'd say it varies quite a lot.
Another question. As our organizations become more and more complex and new manipulation paradigms arise, such as AI, do you anticipate other modeling layers on top of the existing recommended ones, i.e. conceptual, semantic, etc.? That's from Raul.
It's a good question. It's not something I've given any thought to. Off the top of my head, it's hard for me to imagine right now anything at a higher level than semantic or at a lower level than physical. That just means I haven't thought about it and challenged my imagination.
Okay, question from Mark. What is the difference between data linkage and data interoperability?
Data linkage is one form of data interoperability. I would love to spend a bunch of time on this. I am next month at Enterprise Data World in Orlando doing 3 hours where I'm talking through data interoperability, where data linkage is a form, a hyperlink approach to data is a data facts. There's several forms of data interoperability, and it's an interesting architectural challenge in which pieces do I put in place where. That's I think one of the big challenges for data architects today, if they're going to address interoperability, is there's half a dozen ways and probably 40 or more technologies out there to support data ability. And maybe one of the we have in adopting those technology is knowing where to fit what in.
A related question, is data interoperability an aspect of enterprise application integration? That EAI, those message brokers and APIs that connect, that push data between applications in real time or batch.
Okay, I don't think either is a subset of the other, but I think they overlap, because a message hub is one form of achieving data interoperability.
Okay. Your audio is a little better. We're still getting some repeated words for some reason, but maybe turn it down to another smidge. Let's see, did I miss any? Oh, here's a good question. How would you model streaming and sensor data?
Sensor data is typically a measurement, time at the timestamp, and identification of the sensor that took the measure. I would model all of that as if it were a flat document, not a nested document. So I'd think of it in the same way that I would model JSON.
Okay. Cool. Let's move on, Dave.
All right. So I've said we need semantic for data interoperability. And here's the story I'm trying to tell, is that we've got all these different kinds of data. We've got multiple operational, transactional systems and operational systems other than transactional, operational IoT systems and so on. And each of these has their own data model, whether it's been modeled or not. They have their own data structure. They have their own data some definitions, language, meaning. I find myself referring to these things as dialects. And then we have multiple data warehouses, and we have data lakes, and we have NoSQL data in document form, in graph form, and so on. And if we want to interoperate, we need to be able to let these things talk to one another. The way we need to get there is for each of these data collections, data sets, databases, we need a data model for them that expresses it in its local dialect. And then we need an enterprise model that is not about a particular data set or a group of data sets. It's about the things in the enterprise and the standard terminology that we're going to use to talk about them. Then we can take any individual database, dataset, data model, map it to the semantic model, and now we have the ability to express every data set in language. So we can do model to mapping from each individual model to the semantic model to say what it means in our common language is this. So that's what semantics is. It's the ability for me to get to a standard vocabulary, and what I want to do to achieve that is express it as ontology, where the ontology is represented as a property graph. Then I can extend it with taxonomies with standard classification structures. If I end up with standard terminology, standard definitions, describe all the stuff that I have that I'm working with in database, then I can begin to get to interoperability by making these things talk to one another through a semantic layer in all of those forms: linkages, products, APIs, message hubs, all of the various ways that we can make interoperability happen.
Okay, I got so many questions. Yeah, so I harken back to the early days of data warehousing, like the first 10 years at TDWI, and we were teaching people how to build data warehouses, and it quickly became clear that you shouldn't waste your time on an enterprise data model because you would never finish. And by the time you did, the business would have changed too much. So are we recreating the enterprise data model in a slightly different form here? I guess that's my first question. I'll just leave it at that for now.
All right, I would say in some respects we are recreating the enterprise data model in a slightly different form, but we are not trying to stop the world from turning and do it all at once.
So how long does it take to do this? I guess that's the follow-up.
It's not a project, it's a lifestyle. You're not going to get everything to interoperate big bang all at once. You're going to go where you have a problem. You're going to model enough to solve that problem. Then you're going to go on to the next thing and model enough to solve that problem. And you are going to organically grow this enterprise semantic model that will never be finished, because your business world keeps changing, competitive world keeps changing, your world keeps changing, your technology world keeps changing. So this semantic model has to become a living, breathing thing that evolves and grows over time.
So if I'm building a solution, like a data analytics solution, right? I'm going to model the data. I'm going to pull it from these different sources. I'm going to model it with a star schema or some other kind of schema. And I think what you're saying is that, okay, that's great. You need to do that. But before you do that, create the semantic model or look at the existing semantic model you have and find out are there any new sources? How do we model those? How do those map to semantic model? And then build your new analytics solution and that model from the semantic model. Does that make sense?
That's part of the story. So you're only ever going to have one semantic model. You're only going to build it from scratch once, the first iteration. After that, everything that comes into play is going to be addition to and sometimes adaptation of that semantic model. That's how you're growing it. So each time you undertake something that is working with new data or new need for data to communicate with other data spaces, then you're back to modifying, adapting that semantic model. So, yeah, I would say always with something new, go back to semantics.
Right. So the first step, when I'm building a new data mart using a cube or whatever technology, the first step really is to extend the semantic model to support what I'm trying to do, and then build the conceptual and logical model from there, right?
Yeah, extend the semantic model or ask the semantic model already represent what I'm trying to do.
Got it.
That's okay. One of the things you're going to get as you evolve a semantic model over time is less and less new stuff. More and more, we've already represented this.
Yeah. Okay, so I guess the moral of the story is to work iteratively and build out your models from the semantic model, extend that with each new solution.
Yeah.
Okay, we got a ton of questions here. Eric says, usually before trying to work in data, you have to convince the business side to do those types of projects. How can you use a simpler model to get some traction, understanding, and be able to connect it to more complex models afterwards? Well, I think you probably just answered this.
Yeah, you can always start with a very simple model. The cool thing about the graph model is if you start with a knowledge graph instead of a property graph, you're just drawing circles and putting nouns in those, drawing arrows that connect those circles and putting verbs on those lines. And you're not into anything complex. You're not into anything scary to the business. I have a circle that says customer. I have a circle that says vehicle. I have a line that says customer rents vehicle. If we could get business to communicate in this form first, then we can begin to add the complexities of the models that ask, okay, so what facts do we want to know? As soon as I've seen the facts, I've made the shift from a knowledge graph to a graph.
So knowledge graph is a really good semantic model then.
Knowledge graph is a good high-level semantic model. And then I drill it down because I can't describe all of the semantics at the level of things. Sometimes I need to describe semantics at the level of properties, attributes in ER language.
Mm-hmm.
So I start with a knowledge graph, I extend it to a property graph, and then if I need to understand classification status or type, then I add taxonomies into the property graph. But I can certainly start with that knowledge graph that is super simple, doesn't look like a bunch of technical babble, and is really comprehensible to the business. I can even do, this is a trick I learned years ago from a guy that I worked for, Mike Brackett. He says, if you want to get the business engaged, go up to the whiteboard and draw something that is blatantly wrong. When they jump up the eraser, you've got them.
Okay, that's a good way to engage the business. I've pulled that trick myself once or twice. Okay, another question. Wonder if others agree that vendors seem to be marketing tools in a way that implies that modeling is not important. That's so true. Pushing tools into business users' hands and non-technical hands and promoting magic and no need for this bureaucratic enterprise concepts and structures. Agree, disagree, Dave?
I would say I found a kindred spirit in cynicism here.
Yeah, well, I'm right there with you. I definitely see that.
Yeah.
And that's why we have a new generation doesn't know anything about even dimensional modeling, let alone semantic or conceptual modeling. So I think Brad made another comment. You just claimed the enterprise solution doesn't work because it is never finished, but also said the semantic modeling you are promoting here is also never finished. Yeah, I think those are both true statements, right?
Okay, I'm not going to say that enterprise solution doesn't work because it's never finished. I'm going to say enterprise solution helps you to move along the path to something where we have nothing that's ever going to make it finished. The world keeps changing around us. That's why I say it's not a project, it's a lifestyle.
All right, question from Connie. Would it make sense for the semantic model to start with information concepts from business architecture reference models, for example, the Business Architecture Guild, that are relevant to the organization to get a bit of a head start?
That could be a very practical way to get started, and that's sort of taking to semantic modeling the concept that guys like Len Silverstein and David Hay have tried to introduce with universal models.
Yeah,
that's a very practical idea. I love to do this stuff. I learn from it too.
Mark wants to know thoughts on the lake house -knowledge graph hybrid idea. What would the tech stack look like?
That's kind of a thorny question.
It's mixing and matching things.
The thing is, in the lake house, you actually have multiplexers. I don't think you can do it all as one model.
Yeah, it's kind of a data dump, right? And you may have portions that are modeled, portions that aren't.
Yeah, and even the portions that are modeled, you're probably going to have different models in different zones.
Yeah.
So that is probably pretty practical. And again, then the value of those different models in different zones would in part be mapping them up to the semantic model so that you can have them engage in data interoperability.
Yeah, so we're going to talk about the medallion architecture and zone-based modeling in May when we finish this series with Carlos and he gets on. I know he always has a dimensional model in the mix. That's his analytics zone. I don't know how much he models the other zones. Anyway, we'll learn about that when we get to it. All right. Alexandra asks, how do we solve issues of reconciliating dialects? Could you elaborate on how those message buses, APIs, etc., would be used operationally? What would they do? Is the issue about how to propagate data changes within the enterprise semantic? And then it stops. Data model.
Okay, so let me try to think through this. Reconciling dialects. I treat data silos as each having sort of their own dialect. The reconciliation has to come at the semantic level, recognize two different terms, two different silos as having the same meaning. At the semantic model level, I need to decide what is the standard term. And then when I model the semantic level, and let me go back and say something I probably should have said earlier. In this semantic model, it has to be more than the diagram. Everything in the semantic model needs a definition or description. If I don't have standard definitions, I still don't have standard semantics. So I get the definition or description there now. In that definition or description, I can begin to itemize synonyms or aliases. So that's one way I can do it, is in the definition or description. Another way I can do it if I want to implement my semantic knowledge in a graph database, because I built it as a graph model. I implement it in a graph database, I can begin to put those synonym terms out there as is synonym of, is alias of.
Yeah.
So that I can have my standard terms in the model and then associate them with all the various dialectic variations.
It almost sounds like the semantic layer is a combination of a conceptual layer and a business glossary. Could you think of it that way?
That's a bit of a story.
Okay. I'm also thinking that youngsters might think this is way too much work, right? How do you get them to slow down and into business here?
Well, I guess when I'm thinking semantic model, I don't want to put that in the hands of developers. I don't think that's an engineer's job. I think that's an architect's job.
Right.
And I think maybe the problem we have with the way we're working today is that we're putting this on engineers without having done an adequate job of architecture.
Yeah. No, I see that all the time.
I think semantic modeling and interoperability are today's pressing data architect challenges, and something that architects need to step up to. If we can put the semantic model together architecturally and make it then the engineers become responsible for maybe architects and engineers share responsibility for the conceptual model. Engineers have lead responsibility for logical and physical models. Then maybe we've got this thing working as data teams.
Yeah, and the one thing that we see all the time is that maybe the architect, when they set things up, did this, but then things kind of get out of hand, people get busy, and the architect fails to oversee the new stuff that's going in and whether it does actually reconcile with the semantic model. and many other things. In other words, there's not enough architectural oversight into what's being built to keep it coherent and usable. When it becomes non-coherent and fragmented, there's you just have a data dump, which is a very expensive way to manage your data.
Right. And the whole rest of Alexandra's question about how you're going to use messages, bus, APIs, can't give you a good short answer. That's why I need 3 hours of enterprise data work through this, because there are so many ways that you can use them.
Yeah. So Dave, we've got about 8 minutes left. I think we've got 2 slides left. So why don't we power through those?
Okay. So this then is what I think is the essence of the story here. That we have data supply and we have data consumption. And we have data supply and data consumption in a variety of dialects. We have operational systems, data warehouses, data lakes, master data management, operational data stores, data lake houses, lots and lots of different ways that we have data in the supply zone, each of them with their own structure, their own semantics, their own language. And then we have data consumers, some human, some soft, some algorithms that want to access data, get access to data services. And some of those data consumers have their own local language and terminology. And so what we need in the middle is data translation. And this is the essence of what we need for data interoperability. So data suppliers, they provide data starting out in their local dialect, and based on that semantic layer, it needs to go through some translation to be served to the data consumer based on the semantic standard. Then it's the consumer's responsibility to understand the semantic standard and translate to their local dialect. When requesting data, the consumer may request in local dialect, but an API or something has to translate to semantic standard, or vice versa, so that we can go to the data supplier requesting data from the semantic standard language, and let the supplier interpret what that means relative to their local data dialect. So we need translation going both ways, and this is what gets us to interoperability. And you can see in the middle here, there's all kinds of ways to make this translation happen. And this is part of the architect challenge too. We've got semantic layer tools, a bunch of them, a handful listed here. We've got some open source model-based abstraction. That's where DBT comes in. We've got data virtualization tools. We got semantic layer and BI tools, but they're not them full featured semantics.
So Dave, when I look at this, I'm like, yeah, we need a translation layer, but this looks like semantic layer wars to me. Like, you got a battle of which semantic layer is going to be the truth, right? How do you reconcile all these things? Because most companies have at least half of these things.
Okay, you need to choose a standard. It's not semantics without a standard.
Yeah.
So all I'm showing here is all the possibility. And if you work in a world that implements all of these possibilities, it's insanity.
Yeah.
So you might say that we're going to build a semantic layer that is going to do a combination of abstract data layer and data virtualization, two things that play nicely together. And for our abstract data layer, we'll go with DB2, and for our virtualization, we'll go with Denodo. Okay. Now I don't have semantic wars. Now I have common sense. So you have to think. This is the place where, in addition to the data architect, you're going to have some technology architecture come into play here to make sense of all of this.
Yeah.
But so all I have in the middle here in blue is just saying there's lots and lots of things that are possible here. And to build a good semantic layer, you're going to have to be selective about how you want to approach that semantic layer, which things you want to use and how. I'm kind of a fan of the combination of virtualization and graphs. But I also see some good in data linkage and the zero copy stuff that a company like Cinchia is doing. So, but you're going to have to pick and choose, and you're not going to find one tool that does it all. So you're going to have to think about how to fit those tools together. And some of it's interoperability among the technologies.
So George asks, data decentralization with data mesh, empowering real-time decisioning, generative AI projects are moving data decisioning to local projects. Are there use cases, success stories that show value in data architecture oversight? Well, when you decentralize, you have to have strong governance and strong data architectural oversight, or the whole thing just implodes. My cynical self, Dave, says, data mesh is just giving legitimacy to data silos. It can work, though, if you do have strong oversight, governance, and architecture. I think you would agree with that.
I agree that data mesh require both strong architecture and strong governance. And I also think that it's silly to think that you can go 100% data mesh. And you can weave domain data management into other data architectures, data fabric, data lake house. You can weave domain data management into that, and sometimes it makes sense. But full 100% data mesh, I'm kind of about that.
Yeah. So Dave, let's go to the last slide here. We got 2 minutes before the official end. I know we have some outstanding questions and comments. I think some people have been putting the questions in the chat, which I just saw, but all right. This is the second to last slide. You added this. Okay.
No, this now should be the last slide.
Oh, it is? Okay, good.
And what I'm doing here is trying to pull all of this together and say, if I've got a strong layer, smart APIs, and well-defined data products, well-designed data products, I can get to data interoperability. But it depends on this strong semantic layer, and none of it's possible without data models. And it's not just the semantic model, it's all of those models that I need to map to semantics for data translation. That's my story, and I'm sticking to it.
That's the thesis. Okay, so go down to Enterprise Data World in Orlando and hear the full story, right? And when is that?
March 25th, maybe 24th, 25th, somewhere in there.
Okay. All right, so we have a few outstanding comments we'll address. Obviously, it's 2:00 Eastern here, so if you have to go, thank you for tuning in. If you want to sign up for 30 minutes with Dave, I hope you put your request into the chat. Connie asks, I might have missed it, but what about knowledge graph databases that support inference? For example, Stardog and others as semantic layer to utilize the inference capabilities of OWL.
Yeah, this is powerful stuff, and it does have great potential, and I've not brought it into the mix here intentionally, because one of the things I find when I go out and talk to people about semantic modeling is they shy away from it. They're scared of the complexities of RDF and L. So when I'm trying to introduce semantic modeling, let's start out with the simple knowledge graph, property graph, as a visual thing. It's simpler. We're drawing lines. Okay, now that you're comfortable with that, let's layer in some RDF. Now that that's working for you, let's add in OWL. And maybe I'm not limited to the NoSQL graph databases anymore. Maybe I now have potential to go to triple stores. And there's a lot of power, and tremendous amount of analytic power working with data as triples. So the power of RDF and L in connecting data is really something that's almost a big shift kind of thing. getting traditional data management people to go there in a giant leap is probably cultural. So if we take this step of semantic modeling, semantic mapping, without bringing in the RDF and L aspects, we've made a step along the path. And then beyond that first step is the potential to go RDF and L.
Yeah, so on the flip side of that, the easiest way to get going, I think you mentioned a knowledge graph, to do the semantic model. Are there other tools? A couple people have been asking that.
I can't give you another tool at the top that's going to do this and do it well. I think graphing is the future for semantic modeling, because bottom line is semantics has to express ontology and taxonomy.
Good. Well, Dave, I think that's a good place to wrap up. You got a number of takers on the offer, Dave. So obviously, if we will connect you with Dave, and you guys can arrange a time to talk. If you're going to be down at the event, that would be an ideal place to do it. But with that, Dave, thank you so much for sharing your insights and knowledge and wisdom about data modeling. I know we just scratched the surface. We could go for another. Well, I know you've taught data modeling as a week-long course, so I mean, we could go forever on this topic. Okay, well, thank you all for attending. I hope this was valuable, and I hope you tune into our next event. Actually, I'm supposed to share my slide. So our next one is March 8th with Brad Schwartz on the power of intentional leadership. So hope to see all of you there. Spread the word. We're a little guy out there competing with the big boys. So if you like what we do, please let others know. And we look forward to having an ongoing conversation with you on these topics. Thank you and have a great day.
Thanks, everyone.